get to it. We're going to keep things moving quite swiftly today, but let's also keep using the chat. If you have questions, comments, jump in there. Alejandro's on hand, as always, to help out too. Yeah, it's going to be a really great call. Okay, let's get to it. Britannia, over to the next
We're
slide, please.
good on share. Okay, good. We're good on screen share. Perfect.
It's looking good. So that's right. We'll do an intro. We're going to have our lightning talks from the top teams, celebrating everyone with a speed round, going through all teams really quickly. And then we'll have a 15-minute break for the judges to deliberate. So at this time, we'll stay on the call. The judges will move to a separate meeting to discuss, but you can kind of just keep this tab open while you do other things. About 15 minutes afterwards, we'll come back on and we'll announce who's being selected for the top prizes. So that's what you can expect today. Next, I just want to celebrate an overview of what this has been. It's been 6 weeks. It's been global. I think we've got people from just about every continent and many, many countries represented here today. And most of you have been working together for the first time, which is quite a feat as you establish how to work together, how to communicate, what it means to lead research initiatives. So really massive congratulations on jumping into this work and working with new people. Not an easy thing to do. And we've been pushing the boundaries in multilingual, multimodal, and efficient AI research. I just want to highlight this 6 weeks portion. We know from the beginning, 6 weeks, not enough time to do a research project. We never intended it to be so. But what we hope is that it is enough time to make new connections, to kick off some ideas, and to lay a foundation so that a lot of that groundwork is done and you're ready to keep going. I'll say this again at the end, but even though the expedition is wrapping up, we're not going anywhere. We're still here, we're still on Discord, and we're still doing open science. So we sincerely hope many teams continue their work together, and we'll be happy to jump in and support in a number of ways. Okay, next slide. So Britannia, do you want to talk us through this virtual background thing quickly in case anyone wants to join?
Yes, so the virtual backgrounds were sent in the Expedition Updates channel on Discord, so feel free to download it from there. I think we can also drop the link to that in the chat here on Zoom. And then if you're interested in joining in, I think as Madeline mentioned, particularly if you're presenting, it would be nice to have just a fun background. You can click on the little arrow near video, adjust your background, and then add an image. So if you need any help here, feel free to use the chat here. But yeah.
Excellent, a little way to celebrate, but very excited to welcome here today Kelly, Marzia, and Max, our judges for the closing ceremony. Thank you so much to all of you for giving up your days to join us. I know it's been a lot of information going through the slides, and we're about to get even more today, so really appreciate your time and expertise as we look at this next frontier. So glad to have you all with us today. Next, just a reminder of the prizes that we'll be awarding. We've got a gold, silver, bronze, most innovative and most promising prize. We'll be celebrating this with additional API credits and some certificates to share out. And bragging rights, of course. I think maybe that's the most valuable one. Next up. Okay, here we go. We're getting ready for the presentations. I've been in touch on Discord, but a reminder, we're going to be quite strict about this 5-minute limit. I'll be putting reminders in the, oh no, Marzia, what has happened to your background? Okay.
I'm not going to stop. I'm sorry.
No worries. We'll be quite strict about these time limits to respect each other's time. I'll be in the chat as you kind of have 1 or 2 minutes left to present. It's not personal, but we just want to be quite honest about this. And we'll use the chat for any follow-up questions or time to celebrate. Okay, is the next slide where we start to announce our first group of teams that will be presenting? Here we go. So the group 1 of the first presenting teams, you can imagine our drum roll here. First up, we'll have group number 15, the drafter abides. Excellent. The second group to present will be Group number 3, street art analysis. Congratulations. And group number 8, Aya site. So congrats to these 3 teams. We'll have your presentations and then we'll find out who the next group of teams are. But with that, we're going to put group 15 on the spot. Who will be presenting from this group?
It'll be me.
Nice, Harsha. Okay, congrats. We tried to give over screen toggling controls and weren't able to figure that out. So you'll just call on Britannia and say next slide when you'd like to progress through. But I'll start your time. Looking forward to hearing from you.
Awesome. Thank you for the opportunity to present. First, I want to say that we had an amazing team effort. And congratulations to everyone for that. And thank Katrina in particular for setting up these amazing slides. So the next slide. So broadly, to save time, I'll talk about how LLM inference has 2 stages. The prefill is not what we're interested in today. We're interested in the decode stage where we spend a lot of time basically generating 1 token at a time autoregressively. Weight loading of the model into HPM to SRAM dominates at this stage. And we really don't want to be spending a lot of time here, both on the slide as well as decoding. So the next one. So what we wanted to think about in this project mainly is how we can improve the paradigm of speculative decoding. In speculative decoding, you're using typically a model with way fewer parameters, which can be loaded way faster. And you use the base model or the large model only to verify, almost like a prefill sort of task. In this context, the draft model takes in the input and generates K tokens, and different approaches are used by this. And the speed up is when these draft tokens are actually accepted with the base model. So we're very interested in good draft models. So the next slide. So for good draft models, 2 approaches are using Eagle and Medusa. One uses a multi-draft approach, and another uses a multi-head approach. So the idea is in Eagle, you have 1 set of parameters or 1 head. You generate different paths, and then you verify these paths in parallel. That's what the Eagle approach is. And Medusa actually introduces multiple heads, predicting more tokens in parallel. I'm not going to go too deep into this given the time. So in our expedition results, we primarily focus on Eagle. Next slide. So primarily, we evaluate the performance of speculative decoding using acceptance rate, which defines the probability that a token is accepted, and the throughput, how many tokens per second or requests can you process per unit time. The challenges we mainly address in our project or look to address is we want to address the dataset dependence of speculative decoding, the task dependence, like is it just working for translation and not reasoning? Is it not uniform, etc.? The third is multilingual. You don't want to have 1 drafter per language. That sounds absurd, and switching the weights in and out is a challenge. So next slide. For this, first, we wanted to understand the problem. So the first thing we did is we did an analysis of the shared GPT dataset using command A. Next slide. Then what we did is we actually did the translation, 400,000 sequences. Happy to chat about this offline, but that was a good effort. And we also completely rewrote the benchmark from scratch of SpecBench. Now we get multilingual support as well as fine-grained task and language-wise analysis. Next slide. We also built optimized code training pipelines for both Medusa and Eagle. Now you can do full fine-tuning and say maximum of 2 GPUs even for Aya expands as an example. And Eagle now supports Llama 3.x as part of this. We plan to open source this. Next. Now here's the cool part, what I think is cool. So the first 3 bars were models that have been trained on just the language, a single monolingual data set, right? Just the Hindi, a drafter trained on the Hindi version of Share GPT. The middle one is a drafter trained on the English original version of Share GPT. And the purple was trained on German. Now, it's cool, you do get some speed up, but if you evaluate on a multilingual spec bench, you see that the speed up is not as great. What we instead did is we took the final checkpoint as an initial experiment and did model merging, and then fine-tuned it on only a 50% subset with mix of all these 3 languages. of these versions of shared GPT and fine-tuned it further. We saw that we could get as much as 2.5 times speed up for across all of these languages. And this is not just limited to just Hindi or German. This is a truly multilingual drafter, right? And the next slide. In this case, you can actually see that across most tasks, the model merging, or the model that the drafter that was obtained using model merging has a speed up relative to the specialized language drafter, rather than, it actually improves compared to the specialized drafter across a bunch of tasks. There are outliers, and most of our experiments were for Llama 3.2 3B instruct. But in terms of future work, next slide, just to wrap things up, we plan to do more models, better data sets, improve the model merging, analyze it further, add in a lot more evaluation data, and send a paper in. So hopefully that was on time. Thanks a lot for your attention. Apologies if it was a bit sped up. Thanks again.
Just in time. Congrats, Harsha, and huge congrats to the whole Drafter Abides team. Let's move on. Next up, we've got our street art analysis team. Okay, Alice, nice. I see you there. Will you be presenting?
I will. Very fast, so try to keep up.
Let's do it. Your timer is starting.
Okay, thank you. So first of all, I'd like to thank the support we received from the Cohere Labs, and of course, a special thanks to the very committed street arts team. As I intend to show on the next slides, the diverse research questions we formulated and began to explore reflect our varied motivations, which range from bias and classification between art and vandalism, sentiment analysis, model performance, etc. Next slide, please. Our aim was to use the precious data set we had in hand, graffiti from around the world, in order to ask questions that would allow for a better understanding of the state of the art of VLMs. During the first 3 to 4 weeks of the project, our team was divided into 2 groups, the data annotation team and the technical team. We have logged around 1,000 images that qualify to answer at least one of our 5 questions, and we also developed an internal ethics protocol to guide our data selection process. Next, please. On this slide, you are able to see from where we collected the data to answer to our first research question, where we aimed at finding whether VLMs were able to guess where a graffiti piece is from. For that, we determined that we needed to select images that have distinct cultural elements that make location more plausible for VLMs to identify country based on culture. Next, please. What we did was to analyze performance in 2 different ways. We investigated different models to contrast their accuracy with one another, something we called cross-family analysis, and diachronic versions of the same model, which we called intra-family analysis. Basically, as prompts, we gave it an image and asked from which country it may have been, but with no context. Then we would feed VLMs with the continent and ask for the country. And finally, we would give a list of possible countries to choose from. Funnily enough, even when the prompt specified a continent, the VLM would sometimes return a country from a different continent, disrespecting our prompting and believing its own COT. As you can see from the graphs, the performance of VLMs tested ranked below 60% in any prompts, including the ones in which we used personas. Next, please. Here we show the cross-family analysis, now of prompts requesting for VLM's classification of continent of the graffiti. Again, their accuracy is still relatively low, below 70%. We tried different prompts, and this noticeably affects the accuracy scores for each model. For the intra-family evolution, intern VL3-2B significantly outperforms its predecessors across all prompts, indicating gains from architectural evolution. And surprisingly, we saw that intern VL2-2B performed worse than intern VL1-2B on prompts 1 and 4. Next, please. Our second research question was how well do VLMs perform sentiment analysis on graffiti. We had vivid discussions about ground truth and how to get statistics from humans that were robust, but in the end, we tried to experiment with what we had. So we created forms to annotate human feelings evoked looking at specific artworks. On the forms, we asked for some personal data in order to have an idea of diversity of annotators. We asked them how they felt looking at the graffiti, and we had 13 tags of feelings to be chosen from. Even though we only had 12 respondents on the form that got the most responses, we saw that in some cases, the responses we received aligned closely with the ones the VLMs we tested. For instance, this graffiti in Iran received hopeful and calm as primary and secondary feelings with an overwhelming sum of 50% for humans, and GPT, Gemini, Claude, and Grok picked up on that. Next, please. Next slide. Here we can see that something very similar happened to images from Israel and Malaysia. Almost all VLMs shows the same sentiment, and our measly 12 humans annotators chose. You can see here on the Spitzer graph that some answers we got were very homogeneous, and we chose to use those instead of others where we got different emotions as response because we wanted to make it more identifiable for VLMs. Next, please. Our third research question was whether VLMs was able to see cultural symbols from different cultures in multilingual prompts. We prompted in English, Chi, Portuguese, Spanish, Italian, and Hindi, which are the languages that we in this group can speak and read. We analyzed output from GPT, Gemini, Claude, Grok, and Aya Vision. So we saw some identification problems with the images of Malcolm X and Martin Luther King. We noticed that Aya hallucinates in Italian, and the adinkras were not recognized in GPT, which treated them like mythical animal creatures. We also had problems being understood when we prompted in Chi by Gemini and Aya, but meanwhile, Claude and Rock not only understood it, also gave output in Chi. Next, please. On this one, we have some great visuals. It's unfortunate that we don't have time, but for this research question, we wanted to find out whether VLMs would be able to identify artist style. So we tried to cluster them in Bleep. We didn't see a big improvement from Bleep to Bleep 2, and when switching from K-means to GMM clustering. Even though the artist styles are very obvious from a human perspective, we cannot see this on the machine. Can you please go to the next? Now, finally, for future questions, we have more questions than when we started, but I guess it's a good thing. Each question led to more inquiries, and now we need to review our findings and refine our research questions going forward. Our new questions range from how to create better embeddings to whether there is a pattern for the mislabeling of countries. I'm sure that some of these questions will be answered soon, and some will haunt us until the next expedition, so I hope we can count on you next year. Thank you very much.
Congrats, Alice. Thank you for this presentation and great to hear from the whole street art team. Bravo. Okay, next up, Aya Site. Who will be presenting on behalf of Aya Site?
Hi, so me and Vivek both will split the slides and we'll go ahead and present it.
Okay, love to hear it. We'll get you set up on your first one and I'm starting the timer.
Okay, so hi everyone, we're happy to present Aya Site. I'm Shrimoy and my co-captain Vivek is also here and we both will be splitting the slides and presenting. We're really excited to show you what we've built and thanks to Cohere for giving us this opportunity. Moving on. So our research question is, how can we leverage multilingual and multimodal models to help visually impaired individuals navigate and understand the surroundings? So that sounds like a chunk of text, so let's break that up and make that simpler. So there are a couple of things here. So the accessibility factor in multilingual scenarios needs to be considered, like especially in terms of how the descriptions are generated. A lot of times we observe that for models trained in English and such primary languages causes issues because the description that the model later generates, the VLM later generates by looking around at the surroundings is very terse or very not descriptive enough as it would be in English. And I think another main issue is that a lot of the apps that we have seen on accessibility are primarily also in English. So that way we identify the gap that there is a lot of issues in understanding if we could build something that would have leverage the multilingual capabilities of models such as AI Vision to build something for people who are visually impaired, and that is wholly inclusive, accessible, and supports all of their needs. So moving on, next slide, please. So essentially our app, as I said, we're addressing accessibility. So we want to build an app that, we built this app that could, understand gestures instead of, clicking on the screen, which is very important when somebody has visual impairments because they don't have time to look at the screen or, actually click on the screen. They probably cannot see a lot. So the gestures here are basically the 2-finger swipe down for images, and for videos we have left down to right top for starting the video, right down to left top for stopping the video. And if you could please click on the play, it would play our demo. Yeah. So that captured the video. Oh, you can't hear the audio, is it? Okay, so
Go ahead.
Yeah, so for those of you who can't hear the audio, it's actually not just showing the description on the screen, but it's also using a text-to-speech module to read this out. which helps. And then you can swipe with a gesture to even stop, the live video transcription that's going on. Is basically looking at the video, looking at the surroundings, and giving you real-time analysis, and also reading it out to you. You can also ask the model questions after that. So yeah, that's the current state of development for our app. Next slide, please. Yes, and lastly, the architecture and the user flow, very simple. A gesture-based capture. It can take input, image input. It could take video input, split that into frames, and then it passes this to AI Vision, and then you have the analysis and the text to speech that allows it. There's also a chat functionality, and I'll pass it on to Vivek like really quickly.
Sure. Can you please go to the next slide? So we also have a multilingual support in our application. So it helps supports like 4 languages: English, Spanish, Hindi, and French. I'll just go through the slides real fast because we don't have a lot of time left. So can you please go to the next slide? So in order to, so we thought of having spatial and temporal aspects. Take so the thing is we have when we take any decision in an environment, we need to understand the spatial and temporal aspect which takes place, which helps us understand and take any decision in the environment, like how far or close the objects are, or maybe how fast and slow the objects are moving, basically. So we have developed something called as depth-aware benchmark, which helps which helps us evaluate VLMs on how they perceive the depth and the relative distance between objects. Can you please go to the next slide? Yes. So the dataset has 3 types of questions asked on an image. So the first type of question is how we can compare 2 random objects seen in an image based on how close they are from the user. The second type of question is a short question answering the question answers on of any random object based on the properties of that object and how far or close they are. And the third type of question is we ask the VLM to sort top and closest objects to us which are seen in an image. Next slide, please. Yeah. So the part of the good part of this data set is it has the depth mask associated with an image. So when we ran the baseline just with an image, we got some results, and we got an improvement over the depth mask of that image when we had put when we had asked these questions to an VLM. So this actually helps us conclude that we can use depth mask as a context in this application. Next slide, please. Yes, so future scope for us would be we'll be distilling these models for an offline inference and using other sensors like LiDAR, and having. I also said that we will be also improving the depth-aware benchmark and adding more resources, more low-distance languages in that benchmark. Next slide, please. Thank you so much. And this is our code and benchmark that we have developed.
Nice, congrats, huge congrats to you both and to your see a demo in action as always. Nice, I'm going to keep us moving along. So next up, I think we're announcing our next groups presenting. That's right. Okay, so who will be in group 2? The first team to present in this group will be Afri-Aya, giving sight to African LLMs. Congrats. Next, we'll have a presentation from Decentralizing Synthetic Data Generation for AI Training. Congratulations to Team 6. And the last team in group 2 will be audio integration for IOVision, Team 16. Okay, excellent. A great selection of teams once again. But Afri-Aya, without much warning at all, we're jumping into your presentation. Who will be presenting from this group?
Hi, I'll be presenting.
Nice. Okay, over to you. I'm starting the timer.
Oh, sorry about that. I actually didn't have my video on. Okay, cool. So this is Afri-Aya, and this is the team. Actually, a lot more people. It was a really huge group coming together to try to make this happen. Unfortunately, we couldn't fit everyone in, but let's just get into the project. Next slide, please. So let's just talk a bit about the problem. Frankly, most of the vision language models do not perform really well on low-resource African languages and cultures. So we're going to be using languages and cultures interchangeably throughout this presentation. And so we want to evaluate the current state of vision language models. And then we also want to focus particularly on the low-resource African languages, like we mentioned. So 2 things that have to be done is that we well, the first thing that we have to mention is that we started off and we wanted to fine tune Aya vision as well, but that kind of went away because of aspects of time. So we're going to focus more on the evaluation side. And so we want to use these evaluations to understand the performance, but also just have a data set that we can use downstream later on for the fine tuning aspects. And so to our investigation, we found that there were three notable pieces of work that had already been done towards this. And so we found CVQA, we found M5, and ALM bench. But still, the number of languages is still quite few. If we can go to the next slide. So yeah, we can just see a broad set of this. And even in our investigation, we found that the number of languages are quite few. And even across the different data sets, there's very little in terms of like the actual languages that are being shared. So you can see that only about one language cuts across all the three, and then there's only about like 3 other languages that you find in 2 or more of the data sets, and only a couple of other languages that exist. But even still, we found that in the quality of the actual data sets that are being created, that varies across different data sets. So you'll find one with multiple choice, you'll find one with more different things, and we wanted to bridge that gap and create something that's more robust and more diverse. Next slide, please. And so how exactly do you go about picking this data and creating this data? So the first thing that we needed to do is that we needed to get data that's culturally relevant. And so we started with the actual idea of going out to Wikipedia and generating, what do you call them, keywords, culturally relevant keywords that could actually be able to augment the searches that we're going to be able to make. So once we generate those culturally relevant keywords from the Wikipedia pages of these different languages or cultures, we then use that with a library, which is the Bing downloader library in Python, and we're able to download different images. Alongside that, we're also augmenting it with users capturing everyday images from their different surroundings. And finally, we have a data set of greater than 500 images per culture or language. We then use Aya Vision to go ahead and caption that. And using all the metadata that we have collected along the way, we then feed that into Gemini 2.0 Flash to be able to generate one cohesive set of questions that we can then generate from the actual data sets that we've collected. So out of all of this, we have a caption data set. And so we manually review that to finally come up with the final pieces of questions and answers that we're going to include. So something of note is that we are building on top of the works that we have already seen previously. So we are trying to make sure that we actually make that compatible. Going to the next slide, please. All right, so this is a walkthrough video, but it might take some time. This is just a platform of where we're captioning. I think we'll just skip to the next one since we don't have so much time left. But there you go. So Afri-Aya.xyz if you want to actually check that out in detail. So what failed? So one of the things that we actually thought that was going to be very easy, and the reason as to why we thought that we could fine tune is because we thought we could just get existing data sets and we could just be able to translate them. The reason as to why that's a problem is that we came to realize that African data on its own is probably very hard to come across in the wild. And that's also something that we found in the research that was leading up to this. So we were not able to do direct translations for many of the data sets that already existed. Next slide, please. And so what were we able to do? We were able to come up with 15 languages that we're going to focus on. We were able to have 1,000 Q&A pairs verified, 251 images that were also verified. And then at the end of the day, we are still going ahead and we're still coming up with the final Q&As. So we're still going ahead to verify most of this. Can we go to the next slide very quickly? And so, yeah, this is our contribution. We have about 5 new languages that we have added from different countries, and we're still expanding that. And so we hope to improve the search long-term, and also we also found out that Gemini 2.0 is really good at doing these translations. Last slide. And these are the results that we found. Interestingly enough, Aya does perform really well on some languages that are in the 23 languages that it supports, simply because some of these languages are interrelated. And with that, we'll be taking on more contributions as we progress, but this is basically what we found. Thank you so much.
Thank you, Bronson, and huge congrats to the whole Afri-Aya team. I appreciate this 5-minute time limit. I think when everyone ends, they're a little out of breath. We're working hard over here. Okay, passing over to Team 6, who will be presenting.
I will be presenting. Hello, everyone. So today we're going to talk about decentralized synthetic data generation for LLM training. Next slide, please. Next slide, please. A slide before, please. Yeah, so diversity in synthetic data is a big problem because the models we use to generate these data have already a static distribution from their pre and post training. So given the sampling parameters we try, there is a limit to how diverse the data we can generate from these models. Also, human generated data, it's based on how much diverse the human can write some data. So it's a big problem to have diversity in data generation. Next slide, please. So our problem is that we want to generate large-scale, efficient, and semantically diverse synthetic data sets using asynchronous LLMs from minimum seed prompts without using a static curricula. And we want this to be diversity and distributed efficient. There are already existing solutions, of course, and some of them are not very distributed efficient. The nodes communicate a lot or they're very centralized. And a lot of them also depend on static curricula to encourage diversity. Next slide, please. So our contribution, we aim to generate a method that generates data from a single seed instruction. It doesn't need any priors or any curricula, and it should be decentralized first, and our method scales with the number of nodes that are there. Next slide, please. So in our algorithm, we basically have, we initialize nodes with different random seeds. Then we generate augmentations of the base instruction. From the generated pool of these augmentations, we have a controller that identifies dense areas in the embedding hyperspace and selects candidate negative prompts from these dense areas. Then these negative prompts are used by nodes to steer away the next iteration of instructions away from the already generated instructions. And each iteration, we up a scalar value, we have a guidance scale. So then the generations are further and further away from the already existing ones. Next slide, please. So our method is based on classifier-free guidance used on diffusion papers. And in that, there is a positive prompt and a negative prompt, single. And in our method, we have a base prompt and we have a group of negative prompts, which we can expand as we generate more, so that we can steer the generation further and further away from the already existing generations. Next slide, please. And our controller is responsible for this. It identifies the dense populated areas in the embedding hyperspace, and it selects the ideal candidate prompt from these areas. And then these prompts are then distributed to nodes to be used as negative to steer away prompts in the next iteration of generation. Next slide, please. We use 3 metrics to compare the baseline with our method. We have a semantic diversity metric, which is basically 1 minus the average pairwise cosine similarity between embeddings. We have a second metric, which is the total edge cost of the minimum spanning tree from the embedding points. And we have a hull area, which we PCA the embeddings to 4-dimensional space, and then we calculate the volume of the hull generated by all the embeddings that have been generated. Next slide, please. So looking at our results, we can see that our method outperforms baseline, and it scales to the number of nodes and number of generations. And with those, there is more diversity. Also, the model with model size increasing, we also see more diversity in our method. Next slide, please. We have some example outputs. On the left, we see the effect of our scalar value, the guidance scale. The more we increase the guidance scale, the generations move farther and farther away from the negative prompts. And on the right, we have a tweet example. And there we can see the consecutive adding of negative prompts. So we see we move the generation away and away from the already existing generations. Next slide, please. Here's our appendix, and thank you for listening.
Excellent, right in time. Thank you so much for this presentation and huge congrats to your whole team. Okay, moving on, we've got team 16, audio integration for Aya Vision. Who's presenting for this team?
I'll be presenting, thank you.
Let's go for it. Your time is starting, Derek.
Great, so good morning, everyone. I'm Derek. I'm super excited to present our project on audio integration for Aya Vision. Our original goal was to bridge audio and visual AI to create more natural conversation with LLMs. Today, I'd like to say that we've definitely surpassed this goal, not only enabling users to talk to Aya, but also toggle between numerous open source models. Next slide, please. So the problem that we have today is that most voice assistants sound robotic, can't handle multiple languages well, and struggle with context. We want to fix that issue by building upon Aya Vision with its multilingual capabilities to then add speech to text and text to speech to have a more fluid experience. Our approach was to build an open source audio SDK, which enables developers to easily integrate and select their STT and TTS models into Aya Vision. And we've designed this all to be modular, low latency, and to be in real time. Next slide, please. So our SDK includes STT models like Whisper, Faster Whisper, Wave2Vec2, NEMU, and Seamless. And for TTS, we included Google TTS, Grok TTS, and Grok ASR. On the technical side, all our endpoints are built upon Flask and Next.js, supporting HTTP and WebSockets. Next slide, please. Of course, we didn't stop at just the SDK. We also built a full web app to show off what's possible. So it features real-time transcription, multilingual chat, and speech visualization, as you can see in the images below. You could also toggle between STT and TTS models on the fly, upload images, and even see your speech being transcribed in real time. So you could see the different options in Figure 3. We also built a mini chat application in Figure 2, and then Figure 4 is basically all the user inputs. Next slide, please. We also put together a short demo video that walks through our web app. I don't think we have enough time, but feel free to check it out. Here's a few labels to explain the different components of our web app. So we also spoke to it in Spanish. We have chat history, image inputs, as well as toggling TTS, as well as live STT transcriptions. Next slide, please. Getting into the nitty-gritty, here's the system architecture. To keep it brief, only focusing on the audio pipeline of the project. First, the audio from the user is pre-processed to remove noise, then transcribed via STT, then sent to Aya Vision, and then spoken back through our TTS models. Next slide, please. For evaluation and benchmarking, here's the general process for our inference scripts. We benchmarked our STT pipeline using LibreSpeech by loading the model, then normalizing it, computing metrics, and then averages. Here we have a few more details on that, but I think I'll go to the next slide. So here are the benchmarking results for our STT models. I think for this project, we really focused on getting the STT right. We wanted to be as accurate as possible and to capture what the user was exactly saying. Among the top performers, Nemo had the best word and character error rates, while Wave2Vec2 offered a great speed accuracy balance. Now, we've definitely got more models other than these in our SDK, but we're continuing to benchmark and test them. Next slide, please. So to summarize all of our innovations, we basically built a model-agnostic audio pipeline, real-time interaction with vision and audio, and a lightweight UI and robust SDK. All that will enable you guys, future developers, to easily integrate and test your audio models. Next slide, please. Of course, we had many hurdles. We had latency, noise handling, and integrating models cleanly into Aya Vision. But looking ahead, we have a lot of plans. So first off, we plan to optimize and quantize our models. add even more STT and TTS support, and develop even more sample apps. So maybe something like a personal assistant like Alexa, where it activates when you say its name, like, hey, I have vision, and then it turn on. Next slide, please. So thank you all for listening. This project wouldn't have been possible with our incredible team and the support of the organizers, mentors, and especially you guys, the community. I had a blast throughout this expedition. Thanks again.
Congrats, Derek, and congrats to your whole team. Great to hear it's been such a positive experience. Awesome. Okay, let's move on. Oh, we're announcing our next group. Okay, group 3, who will be presenting? Back to our drum roll. The first group presenting for group 3 will be group 2, Maya V2. Congrats to the Maya team. Next will be Group 5, Knowledge Explorer. Awesome. Looking forward to hearing from this group. And the last group in this group will be Assessing and Enhancing Burmese Language Understanding in LLMs. Congrats to all 3 of these groups. Really looking forward to hearing from you all. But Maya, not a lot of notice to your team. Who will be presenting?
Yes, Nahid will go first.
Okay,
Nahid?
Nahid, over
Yep.
to you, and I'll start the timer.
Yep. Hey everyone. So this is Nahid, and Karthik is here today also. This is, you see on the slide, the V2 team, Maya V2 team. Some of you are familiar with Maya from the past. Next slide, please. So quick recap on the V1 really. So last year we did build this vision capabilities in the Aya 8 billion language model. So what were the key accomplishment? Like we built a multilingual pre-training data set across like 8 languages. We cleaned the, almost cleaned the data set in terms of toxicity, and eventually built a multilingual VLM that can understand these 8 languages. On the right, you see the model has been downloaded like more than 1.7K time, the data set downloaded, and you can see the language support there. Next slide, please, Madeline. Yeah, so what is the goal of doing Maya V2 really? So improve this language model, so the vision language model we have, Maya V1, beyond how it performs today. So there are a couple of approaches. So one is definitely like we can improve a lot on data, and we can improve on the model architecture / certain techniques on that. So for this expedition, we really focused on improving our data set quality, and we did sort of like 3 different types of experiment for that. And on the next slide, Karthik will go ahead and talk about it.
Yeah, so as part of our experimental setup 1, what we did is we re-engineered our entire captioning process with including evaluations like to find out if there is a GPT value that didn't get translated. So we expanded our language support. Now we did the translation across 23 languages, and we totally created 12.6 million image caption pairs for pre-training and 15.3 million for instruction tuning across 23 languages. Next slide, please. And as part of our experimental setup 2, part A is first we wanted to understand clearly what kind of categories does our data set have. So to do this, we did some technical workflow, like we used a clip model to extract features from the images. Then we used clustering methods, and we removed outliers for each individual clusters as well. And then we identified there are 19 different categories across our data set, such as houses images, clothes images, electronics, landscapes, etc. Next slide, please. So as part of experimental setup 2, now part B is to improve these captions, because earlier we observed that in our previous training process, our captions are too generic or one-liners. So we have improved that with the image textualization pipeline, where we have used several computer vision experts to extract a lot of metadata, and we also generated brief descriptions. Next slide, please. Yes, so once we get all this metadata, we send it to a large language model with a meta prompt, and then rewrite the entire caption ranging from minimum of 500 tokens to 2048 tokens. Next slide, please. Yeah, so as part of experimental setup 3, now what we are doing is we are expanding our dataset coverage. So for the pre-training, as we already identified, it has 19 categories. Now we are trying to find out the missing categories, which is X. We also know the total categories. So we want to fill out these missing categories by doing web scraping, and there are a lot of open source. As part of this, we also observed that the current dataset doesn't actually contain cultural reference images across the languages that we support. So this is a quick thing that we wanted to do. Firstly, to improve the cultural level agnostic of the model as well, to understand there are different cultures and images. And for the instruction tuning dataset, we want to extend it using various benchmark training datasets. Next slide, please. Yeah, now as part of our evaluation, we are doing across these different evaluation benchmarks, but the gray ones that are not actually supported. So we are actually adding these gray evaluation benchmarks to our evaluation pipeline currently. So far we have the dataset preparation done for both pre-training and instruction tuning for experimental setup 1 and 2. The model training has completed for experimental setup 1. Setup 2 is in progress and evaluations are in progress. So the key contributions will be, you will have a new data set that is not, there is no other data set like Maya dataset, because there is no cultural or translated language, vision language model, both pre-training and instruction tuning datasets. Now we are also going to release metadata, model weights, code, and an accessible model by this month end. That is our rapid progress. Yeah, next slide, please. Yeah, that's it. That's what Maya V2 is all about. We are hoping to release the Maya V2 this month end. Thank you for Cohere Labs community to give this opportunity. Yeah.
Congrats, Karthik, Nahid, and your whole team. Always great to follow along with the progress of Maya, which started in our expedition last year. So very cool to see how this progresses, and maybe we'll look forward to see V2 of some of the other groups at our next expedition. Okay, next up, we have the presentation from the Knowledge Explorer team, who will be presenting here.
Hi, everyone. So I'm going to be presenting on behalf of my team. So this project is about evaluating whether AI agents can serve as an alternative to traditional teaching and learning methods. Next, please. Okay, so motivation behind this project was to enable personalized learning for the diverse learners. So like we can see in a classroom, we have diverse set of students. So some learns a topic very quickly and some at their sweet time. So I mean, some take their sweet time. So just to enable all sorts of students. So this app is designed, and we are also targeting multilingual support. And currently our uh, app supports Hindi, Spanish, and English. And we also, and yeah, motivation was also to enable the user to learn from visual graphics so that they can understand the topic better with the help of audiovisual aid. Um, and there was one more factor which led us to design something like a wrap, was that students usually find difficulty in discovering advanced and related topics, so our app enables them in this area. Next, please. Yeah. So significance of our work is that it goes beyond simple content delivery. It aims to create a personalized, intelligent learning experience that adapts to individual learners' needs. By combining topic structuring, storytelling, and visual explanations, it replicates how expert human tutors teach complex concepts. So let's say if we are able to achieve all our goals, I mean, we have a couple of targets, but so far we have been able to achieve just I mean, a couple of them, but some are still in the pipeline. So let's say if we are able to achieve all of those, then we will be able to deliver a very strong, personalized, and engaging learning experience to all kinds of users. And we also plan to expand it to more languages. Currently, it just supports 3, but I mean, we have tested it for 3, but it can support many more languages. Um, and we also we also plan to scale it to a bigger level. Next, please. Okay, so contributions so far. So so at first we start with the structured topic decomposition with the help of AI agents. We have used command R model to decompose a bigger topic into multiple subtopics, and then we have used RAG for effective context specific information retrieval, and then uh, then we generate stories based on the input content. Uh, and then we also plan to I mean, this is still in the works. AI generated visual support is still in the works, and we haven't been able to complete it as of now. But yeah, we in the past few days we were able to target multilingual support, so this is done. Next, please. Yeah, so this is the whole agent flow. So so the user enters the topic, and with the help of command R, Commander again, it splits the topic into multiple subtopics, and and then with the help of a re-ranker, I mean, this is the whole RAG setup. From other end, we have books as input from, and then we are doing similarity search, and based on that output, we are re-ranking the, I mean, extracted output, and then there is web search tool, which is still in works. We have not uh, this is still in works, but we have employed chat history tool thing in our work, and at the end we are able to receive the stories, which I'll show you in the next slide. Next, please. Yeah, so implementation and evaluation plan. So for the backend, we have employed LangGraph and LangChain, and we have utilized Cohere's latest multilingual embedding model and re-rank model. So for embedding model, we have specifically used Embed Multilingual Lite v3.0, and for re-ranking purpose, we have used re-rank v3.5, and so yeah, we were able to retrieve 20 retrieved chunks after the vector search, and then we employed a subtopic divider agent to break a big okay a big topic into multiple subtopics, and then this evaluation plan is still in the works. So we can skip to the next slide, please. Yeah.
We won't have
Can you
time
please?
for the demo right now, so let's wrap this up right now, Drishti. Thank you.
Okay, thank you so much.
Sorry to cut you off there. I'm going to keep us moving along, but the judges have access to your full set of slides. We will resurface it for them so that they can review this backend. But huge congrats to the Knowledge Explorer team. So very cool to see both the vision here and how it's playing out, and really hope you'll continue this work. All right, next up, we've got Team 13. Who will be presenting for this group?
That'll be me.
Okay, great. Go for it.
Thank you. So hello, everyone. It's been a great opportunity these 6 weeks, and I'm happy to get the chance to present what we've done. Our project is to assess and enhance Burmese language understanding in LLMs. Next slide, please. Next slide, please. Thank you. Oh, sorry. One slide back. It was lagging on my side. Okay, today Burmese is still one of the underrepresented languages when it comes to NLP. Two simple reasons. In other words, the challenge is one, a good tokenizer and a good standardized evaluation benchmark. And we believe that in doing this project, we've achieved putting Burmese in a better position for future works, as well as a quasi-bootstrap approach for future low-resource researchers. Next slide, please. For us, the foundation began with data. As we've done and believed to be a good first step, we translated MMOU Lite, a set of questions from global MMU Lite, as a proper benchmark. Secondly, we also believe this to be a nice second step, is to resource a language exam used in an official curriculum. That's Myanmar G12L benchmark. It's a set of Burmese language questions asked at the end of high school students. This benchmark is culturally specific, and it is asked in a monolingual way. Thirdly, to achieve a kind of attempt at multimodality, we curated a driving and writing theory test, which is it's a local test, must be passed to drive here. And along with the benchmark, we developed a bite-sized toolkit to help run these. And we also curated on the other side of the aisle in terms of fine-tuning and continuous pre-training. We retranslated Alpaca and Dolly, about 67,000 roles. And we collected school textbooks and books as much as we can and extracted data for us to be able to tune these models. Next slide, please. So let's talk about evaluation. The mindset we had for the assessment was we wanted to know if contemporary models were capable of reasoning Burmese cultural references. And of course, that is also one part, but what's more important is proficiency. So when it comes to low resource languages, the ability to sustain grammar is still something that needs to be assessed. So for this, we tried our best and collected 7 different metrics, some using LLM as a judge, some with algorithmic processes and regex. So we categorized these generally to either accuracy or language proficiency. So what we really want to say is language proficiency is what you want to see if you are going to use this day-to-day basis. Accuracy is the knowledge, its ability to recall, and this is, we believe, it's secondary to the subject. Next slide, please. We ran these benchmarks across 15 different models, open and closed sourced, and these are our findings. It seems like the overall view is that the majority of the models are still quite in the halfway between being able to speak Burmese and not being able to speak Burmese. But we did see some models being really good contenders, that this is just, they're mainly good models, we believe, because of the context length is very high for these models. Next slide, please. And when it comes to translation, we also tried Comet, Blue, and CHRF. All of these are in quite alignment with our previous findings. Next slide, please. This is a blind test. In addition to the machine benchmarks, what we did was we sent out a survey to 50 Burmese respondents. Of the 4 responses we got from these top models that performed in the benchmarks, just to gauge generally what kind of responses do people favor. And here we found generally the higher end models like Gemini and Cloud seems to be the predictably good performers here. Next slide, please. Yeah, so these are some challenges we've had with the project. There were natural disasters in Myanmar, as you guys might have heard. It was a devastating earthquake. The more technical challenge we had was fine-tuning. We failed to fine-tune the models on the Cohere dashboard and Google Colab because it is quite new to us, and this is something that's been a work in progress. Next slide, please. Time is running out. This is our current attempt on fine-tuning. There's not much to talk about this. We want to do this. We want to make what's there better. Next slide, please. Yeah, what's next? We're going to be here still, hopefully still under the guidance of the Cohere community and the team. So these are what we're going to do, returning more evaluation, enhancing the optimization. Thank you. Next slide, please. Yeah, that's all. Well, thank you again for the opportunity. And we really, really hope to continue more research work under your guidances. Thank you.
Huge congrats. Thanks for the presentation and congrats to the whole Burmese team. Yeah, great to hear about the progress here in just 6 short weeks. Okay, nice. We're down to our fourth and final group of pre-selected teams. Let's find out who they are. The first group will be Group 10, Cultural Biases in VLMs. Congrats to Team 10. Next, we'll hear from Team 19, CodeClarity. Congrats. Following this, it will be Team 27, Code-Based Synthetic Multimodal Data Generation. And we've got a sneaky extra team in this group, I think. Yes, okay, 32, Clash of Civilizations. Okay, we're back in that point where one team has very little notice they're about to present. We're going to pass things over to the Cultural Biases and VLMs team, who will be presenting from this group.
So I'll be presenting for this group.
Madeline, I
Okay.
just want to do a quick reminder that after these 4, we will do our 2 random ones from our generator. So just a reminder we're not done yet. We have these 4 and then we've got 2 wild cards. So
Thanks, Britannia. Yeah, the wildcard teams are still on deck, and I've got my random generator ready to go. So we'll find out who those are after these 4 teams. But
awesome.
nice.
Thanks, Sid.
Sid,
Sorry about
let's pass it over to you, and I'll start the timer for you.
So yeah. Next slide. So yeah. So in this project, what our aim was to basically contextualize and organize the biases that we found in most of the vision language models. We used the images from the OpenAI's clip dataset that had the GPS coordinates of and they had their country level annotations. We also we wanted to look into the various aspects like architecture, people, food, attire, landscape, monuments, all these things combined that form bias in the images. So we had some experiments and we carried it out through multiple augmentations and we repeated these experiments for around 1.65 million images. Yeah, next slide. These were the models, languages, and the augmentations that we used. The models that we used were Gemma 312B 27. We used the 2 versions of Aya Vision and Gemini and GPT. We restricted our languages for the sake of simplicity: English, Hindi, Chinese, Spanish, and Portuguese. We had 3 augmentations: grayscaling, rotation, and adding noise. Next slide. So as a baseline, what we had the experiments for 3 different type of MCQ, 3 different type of generation. One of them was open-ended. This was done through the following JSON schema. We had the country name of the country. We wanted this from the output: the country name, the confidence score, the features, and the reasoning. We further repeated all of this for grayscale and the noisy outcomes. Next slide. So yeah, as I was speaking about the random, we repeated these for we had another experiment which was MCQ with random labels. In this particular one, we just had 4 different choices, and the choices were randomized so that they were shuffled so that the distribution of index was equal. And the schema was same as the open-ended, and it was repeated for all the models and languages. Next slide. In the similar label experiment, what we tried to do is give it a sort of a similar label that was close or to like at least one. It was close to at least one of the neighboring countries or culturally similar country, if there were any. So like, for example, if it's a Mexico, right? So it's bordering USA. So it's culturally similar to Spain, right? Next slide. So these are some of our results. As we can see that most of the countries and cultures were underrepresented. We can see that Africa is most likely in most of these models, such as Aya and GPT or Gemini. Most of these models underrepresented Africa, and yeah, that is what we can see. And next slide. You can see the further that validates what I'm trying to say. Next slide. Yeah, in MCQ random, you can see us further there are some increment to your accuracy due to because of the fact that we tried to make it fair by shuffling our options. But you can see that there is a neighboring bias that it most likely has a bias towards the neighboring from its one particular country, and the neighboring countries are having bias towards that country. So yeah, but there's an improvement here. So next slide. Yeah, next slide. So the effect of language of the prompt was negligible. As we can see that all the languages had the same accuracy. So, but you can see that when we tried grayscaling, there was different outcomes, and hence you can see that in the paper that we'll be publishing in ENMLP. The preprint will be available by this weekend. So yeah, feel free to catch up on that. Yeah. So yeah, this is about it. Thank you.
Congrats. Great to hear about the progress here in your work towards paper. Awesome. Okay, over to the CodeClarity team, who will be presenting.
Hi guys, so again, I'm going to be presenting on behalf of CodeClarity.
You're a powerhouse, Drishti. I think this is the third team you're a part of that's selected.
Yeah.
Okay,
so
over to
this
you.
Yeah. So this project is mostly about evaluating LLMs for code summarization across non-English languages. Next, please. So yeah, we saw that GitHub's own data shows that India, China, Brazil, and Indonesia are rapidly becoming the top developer hubs. And about 80% of the world's developers are non-native English speakers, yet LLM-based coding tools are primarily English-centric. So this was a drawback. So our work addresses this gap by evaluating how well modern LLMs support multilingual code summarization. Next, please. Okay, so why this work matters? So essentially, our motivation was accessibility and inclusivity, and we also wanted to improve global collaboration, and wanted to provide enhanced learning in native languages, and we also wanted to explore research questions like, can LLMs really maintain semantic fidelity across languages? And also we wanted to explore which programming and natural languages perform best, and what are the key limitations and how can they be addressed. Next, please. Yeah. So this was a framework. So at first we took some source codes and generated code summaries, and then we evaluated it using a bunch of metrics and other methods like LLM judge and code semantic metrics and multilingual metrics and back translation metrics. Next, please. Okay, so for dataset and sampling, we essentially sourced a dataset from, code snippets from Code SearchNet dataset, and it included code snippets in languages like, in programming languages like Python, Java, Go, JavaScript, Ruby, and PHP. So, and then we bucketed the function lengths in terms of short, medium, and long. And for each bucket has 17 samples. So this way we try to ensure that there is enough diversity in code length. Although this data set is very small, so we cannot really ensure that, but we tried our best, because for each code snippet, we are gonna have like seven code summaries. So data set was meant to expand. So we kept the seed very small. Next, please. Yeah. So the chosen languages were Spanish, French, Arabic, Hindi, Mandarin, Chinese, and Portuguese. And LLMs that we tested were Gemma 3 9B instruction tuned, and Qwen 2.5 coder, DeepSeek coder, and Code Gemma and Code Llama. And the LLM judges we used were Command A, GPT-4o, and Llama 3.3 70B. Next, please. So to evaluate multilingual code summary, we tried a bunch of techniques. So at first we tried the traditional back translation metrics like Blue4, Rouge L, and CHRF++, Meteor. And then we also tried with the multilingual metrics like BERT score. And later on, we also tried code semantic metrics like SIDE. And we tried this in two forms, like SIDE back translation and SIDE in its original form. And then in the end, we also tried LLM judge assessment, so that we can confirm and validate the results obtained from other evaluation methods. Next, please. Yeah. So here we have got a bunch of plots. So we majorly noticed that Rouge L, Meteor, CHRF++, and I mean all the lexical metrics were having high agreement among each other, and there was and actually correlated with both lexical as well as semantic metrics like SIDE. And model perform consistently well in Portuguese. And next, please. Next, please. Okay, so again, through these graphs, we can see that they align better. And the model that performed the best was Gemma 2.9B IT. And even though it is not a code specific or code specialized model, it did great. And yes, so next, please. And let me just finish it up. Okay, so based on LLM judge evaluation, we found that the top performing languages were Spanish, Portuguese, and French, which are structurally very similar to English. And the ratings were bad for languages like Arabic, Hindi, and Chinese, which are structurally different from English, because most LLMs are trained on English languages. So maybe we saw this sort of observation. Next, please. Yeah, so these were the conclusion, like all the lexical metrics didn't do well, and they were not enough to evaluate the models, and we relied on BERT score and LLM judge. And out of all the models tested, Gemma 2.9 did great. So that is it. Thank you so much.
Congrats, Justine. Congrats to the full CodeClarity team. Great to hear more about this work. Okay, nice. Now we're jumping over to hear from Team 27, Code-Based Synthetic Multimodal Data Generation. Who's presenting?
Oh, sorry. Yeah, I'm here.
There you go. Great. Dante, over to you.
Yeah, okay. Hello, everyone. I'm Dante. Today, I'm very excited to present our research on synthetic multimodal data generation, specifically designed for training and evaluating visual language models. Next slide, please. So the core question we explored is, how can we generate high-quality synthetic multimodal datasets, code, charts, and QA pairs in our case, that help VLMs better interpret structured data? So what does this matter? Existing dataset often lack structured visual content, like plots and charts, and current VLMs struggle with understanding charts or mathematical visualizations. On the other hand, manual data curation is not scalable, so we aim to address that. Our contribution in this project includes, first, a scalable data generation pipeline, Second, the synthetic datasets with size of 10,000 already uploaded on Hugging Face. You can see the link below. And the demo app, also all source code are open on the GitHub. Also, you can see the repository link. Next slide, please. So here's our agenda. Next slide, please. First, how do we generate data? Starting from the top of the graph, you can see our pipeline uses a code-first approach. We start with tabular data, usually CSV from source like CatGo, and then using Command A, we prompt the model to generate Python code that creates various charts, in our case, bar, pie, line, and scatter. And then we then execute this code to generate actual images. Next, at the bottom left of the graph, you can see the model generates QA pairs based on both the data and the charts. This question follows structured templates like which category has the highest value or what is the total value for X. Then we evaluate with the VLM. See the bottom right corner. Next slide, please. Here's the details. We also support open-end questions to simulate analytical reasoning, like summarize this chart or what contribute most to some scores. Importantly, we allow control over input batch size and output size, enabling incremental dataset generation. Next slide, please. So here's the sample charts and QA pairs. Very quick glimpse, the sample. Next slide, please. How do we evaluate the results? So we have two evaluation strategies. First, the numerical checks for completeness in chart labels, titles, or diversity in types of questions or types of charts, and correctness compare the ground truth. And next slide, please. The second method is the VLM-based judgment. Using AI Vision, we input chart images and QA pairs and ask the model to verify the correctness and relevance. Human evaluation is also involved in some edge cases when the model didn't do well. Next slide, please. So here's the results and the qualitative analysis. Look at the top right corner. You can see we have generated a data set of 10,000 rows, as mentioned, and it's comprising charts and QA pairs across 4 chart types. We evaluate 4 popular multimodal models like QVNVL, Lava, and of course, our mighty Aya Vision. So the results show that while some models perform decently, there are significant gaps in numerical reasoning and chart comprehension. We also looked at marginal failures, cases where answers are nearly correct, like on the bottom right corner. So maybe just a little gap in decimal places, helping us to calibrate model expectation more realistically. Next slide, please. So here's the demo. It's a 3.5 minute video, but you can play. Can you play it? We can fast forward it and show some key points here. So please start at the 1:15. Yes, you can see here we can input a CSV and then fast forward a little bit, and you can see you can also prompt the model. We plan to skip this part later to make it more automated. So yeah, keep going, please. A little bit more. Here, yes, here you can see you can choose the rows and columns in the dataset you want to select it, or just selected the input batch size. Then it would be a random selection. We will select a random numbers of rows and columns for you, and then you can go directly to the end of the video. Yes. And you can see here's the generated charts and the corresponding code later on. Maybe just scroll a little bit more. And then you can, at the end, you can save all of these in one click, all the QA pairs and the code and the charts. So very scalable and controllable. Next slide, please. So looking forward, we plan to first enhance the diversity of the datasets because we are only working on 4 types of charts, and we plan to You have some problems working on more diversity charts like a flow charts or radar charts. So we want to enhance diversity to make it more scalable and also more controllable, more diversified. And second, we want to improve the VLM reasoning with our own data sets and other techniques like chain of thought or some rewarding model, reinforcement learning, something like that, so that the model can reason over charts as humans do, not just identify patterns. Thank you.
Hi guys.
Nice. Congrats. Okay, sorry. Over to you, Ashay. Take it away for Clash of
Welcome to the Clash of Civilizations. Imagine this: you ask an AI to write an essay or a news article about nationalism in Spanish, in Hindi, or in Korean. The answers you get don't just differ in language; they differ in ideology. And this project was born out of the realization that political bias in LLMs isn't just an English language problem. It's a global multilingual challenge. And yet, most benchmarks today only scratch the surface. Next slide, please. Language models now write our news summaries, help draft policies, and even assist in legal reasoning. But what happens when those same models promote ideologies they were never meant to? Bias in one language may sound like neutrality in another, and that distortion can quietly influence millions. Next slide, please. So we identified three major flaws in the current political bias evaluations. One, they tend to overfocus on US politics. Two, they almost always test in English exclusively. And three, they rely heavily on extractive Q&A, not generation, which is how LLMs are used in real life. Next slide, please. So we flipped the script. Instead of asking yes or no questions, we prompted each model with open-ended political statements on 12 global topics, from climate to immigration to militarism. For each topic, we asked for a pro stance, a con stance, and a neutral test case. Then, we analyzed the generated text by converting into embeddings and computing political stance as a distance from pro-con centroids. This allowed us to numerically measure leanings across languages, across models, and across a diversity of themes. Next slide, please. Our evaluation spans 10 languages, 5 diverse models, and 12 politically charged topics, from climate change to gender to AI regulation. And this is one of the most multilingual evaluations ever conducted for LLMs. We're not just identifying bias, we're mapping it systematically across different contexts. Next slide, please. So Spanish text, for example, often glorified military innovation, while the same prompt in English leaned cautious or critical. Chinese generations consistently advocated for AI governance frameworks. We don't present these as facts about the regions, we present them as symptoms of training bias, cultural artifacts, or gaps in data. And that's what makes this work so urgent. Next slide, please. So we asked, how much does stance actually shift by language? The global map shows that variance. Chinese and Hindi show high opinion fluctuation across topics, while English and Japanese are more or less stable. What this tells us is that some languages inject more interpretive flexibility into the model's political output, and this isn't just statistical noise. It could reflect differences in data quantity, tone, or regional content representation and training. It reinforces the very need for multilingual auditing. Next slide, please. And here's a surprising pattern. Spanish generations reportedly portrayed militarism in a positive light. One sample read, the incorporation of technology and innovation in military strategy is imperative in the modern era. Is this representative of Spanish-speaking regions, or is it a reflection of model training data that overemphasizes defense tech narratives in Spanish corpora? We don't know for sure, but that's exactly why this matters. We're resurfacing questions that should have been asked years ago in LLM deployment. Next slide, please. Another pattern that emerged with Chinese outputs was a strong support for AI regulation. Statements like regulators, enterprises, and public must work together to build governance frameworks centered on accountability. This could reflect on China's policy climate or linguistic tone embedded in government datasets used during training. But here again, we don't claim causality. We highlight the possibility that the models don't just translate, they politicize. And for global users, that has very real consequences. Next slide. So this project lays the foundation for a multilingual political bias benchmark, one that could eventually guide the responsible deployment of LLMs, because fairness isn't just about one model, one country, or one language. It's about all of them. In the future, we would also like to run our evaluations on real user interactions and give fair representation not only to languages, but to regions where they're spoken. In a world where AI is shaping public opinion, we need to ask this: whose voices are amplified? Whose values are encoded? With this project, we take a step further towards answering that, not just for English speakers, but for the entirety of the world. Thank you.
Thank you, and congrats to the whole Clash of Civilizations team. Okay, we're moving on to our wildcard round. Britannia's taking down her slides. I'm putting up our very official wheel. Can you see it, Britannia? You can nod. Yeah, okay, great. Here we go. The first wildcard team to present. Oh, the drama. Okay, it will be, oh, looks like team 22 is going to be South Asian image captioning. Congrats. Okay, so hopefully there's someone from this group on ready to present. Britannia's going to get your slides ready. And the second group after team 22 will be nice. Okay, looks like team 1 is up. Multilingual legal assistant agent. Congrats on getting our 2 wild card slots. Okay, we'll give Britannia a moment to figure out the slides, but who from, what was the first team? Was it 22? Who will be presenting?
So I'll be presenting this one as well.
Okay, go for it, Sid. You've got 5 minutes on the clock.
Yeah, so next slide. So why do we need, so the main aim of this project was to have a value annotation platform for the images, and make sure that we, we can work towards bias and other long tail problems. We had a lack of a human curated multimodal cultural data set, and for South Asian culture in mixed formats and code mixed formats. And that is the reason why we wanted to work on this. Next slide. So what do we need, right? So first of all, we needed a dataset collection platform, and wanted to put out the annotator guidelines. Furthermore, we wanted the evaluation using the existing VLM models such as Aya. And then we wanted to fine tune our model to improve the performance and release the open source model. Next slide. So our platform has been designed and it's done. We designed it through like we wanted the thought process of our designing was to have a crowdsourced friendly platform, right? With manageable data collection and minimal efforts to changing the data. We added the country names for users to select. We collect the user knowledge relevant to the image data, and we have user information to validate later on. Next slide. So this is our platform. As you can see that we have multiple languages to select from. We have different countries to select from. We have different states to select from, cities, and we have a unique identifier, which will be our email. Then we also have some other metadata that is on the right side. And in the top, on the right side, in the top bottom most two are the ones which are the actual annotations, the captions. So this will be the input from the annotator. Next slide. So an example of the annotations can be seen from this image. We want, we have the ID. We just want to, the country, the captions. So right now this is encoded, UTF-8 encoded, but this is done for a reason, for later on purposes. Next slide. So the unique challenge is basically the primary use of the code mixed format by the people online. So people write English in Hindi, Hindi in English, that sort of thing. That is what we are trying to target. Next slide. So dual purpose utility. So not only that not only for the fact that we are getting the data set, that it's manually curated, but we are also going to have it for the like analytical tasks over the code mix language uses. And yeah, that is one of the reasons why we want to make this data set. And that's, yeah. Next slide. So next steps, what could be the next steps, right? So we can run a full-fledged and data annotation run. We can clean our data, then we have to validate our data. I think this is going to be quite a hectic process, as we all know already. And then we can start the evaluation from the SOTA models, and then the analytical tasks using the human annotated code mixed texts can be seen. Next slide. Next slide. Yeah, so we are done about this. So
excellent, thank you, and congrats on getting selected for this slot. Britannia's pulling up our next group to present, Team 1, Multilingual Legal Assistant, who will be presenting here.
I'll be just 1 minute, like that means video. Okay, testing. Okay. Okay. Hello, hello everyone. I'll be presenting the multilingual legal assistant agent. Our core question was, can a multilingual AI legal assistant agent perform like a real world agent? Next, please. So our core motivation was to make legal access available in mainly developing countries like Bangladesh and some more, and also most of the legal tools are currently available in English. So adding multilinguality in this aspect was also very important. And we also wanted to we also wanted to develop agents as capable as real world advocates and make scalable and equitable legally available for next slide, please. Okay. The core significance of the work is we are planning to make legal access available to everyone at a low cost, and it will also help legal professionals to be more efficient too, and it will help a lot of low resource organizations or peoples too. So these are the significance of the work. Next, please. Okay, so here is our entry flow. So after the question is asked, it goes to a multi-agent system. So we have a rack tool based agent, then one website based, and then one chat history, legal formatting, and document generations are coming. And we used a language based overflow and used ChromaDB as the database. Next slide, please. So for the database, we simply calculate raw legal database of a country. In this work, we only managed to evaluate on Bangladesh, though it is not available. Though like Bangla is not available in Cohere, but it performed really well. And for evaluation, our plan was to like test it against human experts, and for this, we collaborated with like law faculties of like good universities in Bangladesh, like DU and SAS, DU and IOB, and each question was like at least evaluated by two of the faculties. The next slide, please. So here is an example of a question, and our law faculties rated it like 9 out of 10, stating like it is like very well written and cited. The next slide, please. So here is the evaluation. So basically, bar council exams has like 3 steps. Firstly, here is the MCQ. Then comes the written, and then comes the interview or the viva. So at first we tried on MCQs, and we tried on like 2022 and 23 bar council exam of Bangladesh, and in both exams, our agent like outperformed his humans. Like we can see the steps inside. Next slide, please. And then comes the real part. In real part, our agent again outperformed the human candidates, and the steps are visual here. As I don't have much time, let's go to the next slide. So our key findings is like multilingual models with RAG can perform like really well. They have some issues like they sometimes like fail to focus on like focus on like special cases, or like lacks clarity or details. But overall, they are very good. In next slide, please. Done. I'm done. Okay. And so our core contribution is the age agent, and the overall evaluation, and a detailed study on Bangladesh, a country with like more than 200 million people, and we are hopeful that like it will help to democratize legal access to it. Thank you.
Thank you, and congrats to the multilingual legal agent team. And great to jump in on this wildcard slot. Okay, nice. We're in the home stretch, everyone. I'm sure everyone's brain is absolutely full. Britannia's pulling up our main deck again. I think at this point, judges, you can excuse yourself. I've sent you another calendar hold, and your timer is starting. Wow, the tables turn. So you have 15 minutes on the clock. I'm going to share some announcements here with everyone else, but you're welcome to leave, and I'll join your call in a bit. But otherwise, on this call, while we wait for the judges' deliberation, it is time for what's up next, Britannia? Here we go. Nice. Wildcard slots done. Celebrating everyone with our speed round. Okay, this is where we go through all the teams we couldn't get to this time. Let's get to it. I think the first one was our multilingual legal agent, who we just heard from. So let's carry on. Next is team 4. Okay, the multilingual multimodal reward bench team. This team created an MVL reward bench, a benchmark for evaluating multilingual vision models, reward models. And they translated the dataset into 22 languages and found that reward models show inconsistent performance with discriminative VLMs showing promise. So congrats to this team on all your work. Looking forward to hearing more from your progress. Next is team number 9, machine-generated text detection. And this team explored detecting AI-generated text on social platforms using Reddit data. And they showcase the difficulty of distinguishing AI-generated comments from real ones, something we're all definitely up against and a really pressing topic of our time. So looking forward to hearing how this one plays out. Team 11, LLMs for South Asian languages, looked at adapting LLMs for these languages, aiming for a model fluent in 22 languages. They gathered diverse data sets and evaluated model families with Gemini Flash 2.5 and showing promising results. So huge congrats on the progress of this team, and we'll stay tuned for more updates from you. Okay, next up, Ubuntu, a personalized data set for text generation. I know this team plans to keep working, so looking forward to hearing the progress here. But for now, they're working on an ethical data set of historical writing samples for advancing personalized text generation and bias measurement. They focused on diverse data collection in this phase and privacy protection throughout the programmatic information replacement. So congrats to this team on their progress, and yeah, they're still at it, so we'll hear how they progress. Next, we have team 17, sparse upcycling VLMs. This team upcycled dense models into mixture of experts architecture for improving vision language models, and their method achieved a 47.1% win rate against Qwen 2 VL2B, demonstrating the benefits of decoder-driven language generation. So huge congrats on this success here. And then we have team 20, evaluating social reasoning and theory of mind through interactive gameplay. Such a cool team. This team introduced a multi-agent clue-based framework to evaluate social reasoning in LLMs. And their fine-tuned model outperformed benchmarks, achieving 75% exact deduction matching. Wow, so cool to hear this success, and looking forward to more from the gameplay team. Okay, then we have adversarial, team 21, who investigated the transferability of adversarial attacks in VLMs across languages, and they found that English-only attacks transfer strongly, with Gemma 4B showing a broader spread. Okay, cool finding here, and we'll look forward to more from this group too. We're moving on. I think the next team, we heard from this team, team 22. In image captioning. So team 23, understanding how Aya thinks. And this team studied Aya's language behavior, finding low English bias, but varying performance across languages. So they highlighted the need for refinement to reduce English bias and promote non-English capabilities. Okay, then team 25, multilingual, long chain of context with small reasoning models. So cool. This team made STEM reasoning tasks more accessible by translating the chain of thought reasoning into non-English languages. And their evaluation showed Qwen 3 1.7B's strong performance, but struggles with low resource languages. Okay, an important finding here, and we'll look forward to more. Yeah, Drishti is everywhere. Next up, we have team 33, M3 Sportcast Multimodal Sports commenter VLLM. I love this first slide with this demo here. This team developed M3, a pipeline combining optical flow and YOLO V8E for coach grade sports performance evaluation. They focused on fencing as a use case and demonstrated the product to over 100 fencers. So cool. I think we had a magic moment in one of the breakout rooms where it turns out there's more than one expert fencer on the expedition court. So very cool to see this overlap. And the next team, 36, and finally, Aya Insight, the AI-powered scientific summarization team. This team created a multilingual summarization tool for scientific research, something I think we all need. It provides fast, traceable summaries in multiple languages and powered by Cohere models, language models, and RAG architecture. Congrats to this team too. Whew. Okay, I think that got us through all the teams that submitted. Thank you and congratulations on all that you've accomplished. We'll keep moving along. Next, what's up next? Oh yeah, Swag, we'd love to celebrate with you. If you have yet to do so, please fill in our form to all participants. We've got, here, Britannia, go to the next slide to reveal some of the cool stickers. Yes, these are so cool. I can't wait to have these across everyone's laptops around the world. We'll look out for them at conferences and find fellow expeditioners. But you can fill out this form, all participants, and we'll be in touch to congratulate you with these stickers and some other thank yous. Okay, next. Yes, like I was saying, let's keep the momentum going. This is just the beginning. This was never meant to be the end of your research. We sincerely hope you'll keep working together. Maybe you've heard about some teams today that you want to join in on or help out with. Maybe there's other people you can tag in. But in general, my advice is to keep doing what you're doing. If you've got a weekly meeting with your group, keep that momentum going. You're welcome to keep using your channels on Discord. We'll keep them open as private workspaces. And if you need anyone else added there, just let us know. And when you use those channels, it's kind of nice because it means someone from our team is always kind of keeping an eye, and we'll jump in as we can, but don't hesitate to tag us in also. You've got Alejandro, Marzi has been a huge support for many of you, John, who is on, Julia. Let us know if we can help, or tag in me and Britannia, and we'll bring it to the team and see how we can support you. And if you need more credits, our API grant program is always open. Britannia leads that program and reviews applications every few weeks. And so we're always looking for new projects to support if this has spawned a new idea, or if you need to top up to what you've been working on. Okay, what's next? Next is our break. Okay, nice. I see that the judges have been gone for about 6 or 7 minutes. So probably they've got about 7 more minutes of deliberation. I'm going to turn off my camera. We're keeping this meeting open. Feel free to go about your business, get some water, check your other tabs, and we'll see you back here in, I think, about 7 minutes. I'll go check in on the judges now. And congrats again, all. We'll be back soon to announce the recipients of our top prizes. Hello, hello. We're just coming back. Up first to announce our first prize will be Max. So let's reveal the winner and hand it over to Max to announce our first prize.
There you go. Yes, our first prize goes to Team 15, the Drawer Abides. We were really impressed by the background kind of work presented and the technical contributions, including kind of the exploration of innovative techniques like model merging and the solid speedups that the work demonstrated.
Congrats to Team 15, Drafter Abides. Right on. Next up, announcing the most promising, Kelly.
All right, so most innovative goes to Team 19, CodeClarity. I was super excited by this project. I've been wondering for a long time, how do code and languages interact? So I'm very excited to see your initial results, and very excited both to see your future results and also to see how we can maybe close the gap, especially when we get outside of the Latin script.
Right on. Congrats to the CodeClarity team. Okay, announcing our bronze prize will be Marcia.
Yeah. So the bronze prize goes to Team 32, Clash of Civilization. I think it's a really interesting question, how much language models change their opinion when generating different languages, and they did a great job studying this, and also really nice presentation today. So looking forward to the future of this project.
Congratulations, Clash of Civilizations team. Our silver prize will be announced by Kelly.
Okay, so silver prize goes to ISite. This was really exciting, excellent demo, and a really inspiring use case also.
Magnificent, really cool. Congratulations to the ISite team on the silver prize, and the gold prize will be announced by Max. Max, go for it.
Yeah, our gold prize goes to Afri-Aya. Yeah, really well motivated, really well presented. Super interesting methodology, kind of looking at the culturally relevant images, the captioning, like Gemini and the QA generation. I really personally like the manual review by human annotators. That's something that I think is often missing in these kinds of work. Wasn't obviously done at massive scale, but there's lots of data and there's a lot of potential to use the insights from the human annotation to, quality check the rest of the generated data. Yeah, the annotation interface demo, the analysis of how Aya performs on the new benchmark, it basically had everything. Fantastic work. Well done.
Congrats to the Afri-Aya team and congratulations to all teams. Wow, that was not an easy selection that the judges went through. Thank you to our judges once again, Kelly, Marcia, Max, really appreciate your time today, the information overload of learning about so many projects at once. I think we're all due for a nap and probably some inspiration now. Okay, a quick shout out. Alejandro, do you want to give a quick shout out for this hangout?
Yeah, so next Wednesday, we're going to have Research Hangout, and I invite all of you to come and join the call, and we're going to be talking about what you learned in the expedition, so you will have the opportunity to share some of the things you learned over the last 6 weeks with other community members. And yeah, it's going to be fun. It's going to be interesting, and this is for you to share everything you want to share with us. So see you on Wednesday.
See you on Wednesday. Thanks, Alejandro. Thank you. Congrats to all teams. Thanks for tuning in today, and thanks for joining us for the past 6 weeks, and I think 2 weeks before that for sign up. The commitment, the innovation, and the spirit of collaboration is really, really strong in this group, and it's really an honor for you to give your time in this way and to work with us. Like I said, let this just be the beginning. So excited to see where you take all these projects. We'll stay in touch on Discord. But for now, that's it on our side. Have a great rest of your day, everyone, and congratulations once again.